Today we have a machine learning algorithm here to detect images, which is a highly sought after thing from new coders who just want to get into the space and really play around with machine learning algorithms. So first off, you're just going to have to import your files here and import your packages. You want to download CV2, matplotlib, and NP. And it's really important to have these downloaded for the code to run properly. And we're using YOLO here, and the you only look once algorithm. So we're going to need to download the weights and the CFG. So you're going to download YOLO v3 and also YOLOv3.cfg. And this is pre-trained data that works with the model for you and does all the work for you. And this works with coco.names, which is a big class names file that you can use that already has preloaded image names in there for you. And we're also going to use $R here just to read the file. And now we're at the step where you load your own image. So by looking at the coco.names file, you're going to see a list and text file of a bunch of things that you could upload and that it's able to detect. So in choosing your image, you could pick anything you want. Our sample underscore image here is a picture of the Mona Lisa. And that's within the bounds of coco.names because it is a person. So we really want to see if this program is able to predict that that image is a person. So you can upload whatever you would like, just keep it within the bounds of Coco names, and you'll see why it's important to do that later. So what is YOLO actually doing here? It's pre-processing the image to prepare for input to the YOLO network. And this includes resizing and normalizing the image. So your JPG file is already going to be resized and everything for you. It's also going to perform a forward pass to the YOLO network to obtain detection results. It processes the detection results obtained from YOLO network, and for each detection, it's going to use a confidence score that's above the threshold of 0.5. And that's really important because you can change that value to whatever you would like if you want your value to be at a higher confidence rate, but we're just going to keep it at 0.5 for now. And it also extracts the object's class label, confidence score, and bounding box coordinates. It draws a bounding box around the detected object on the image and annotates it with the class label and confidence score. And once it does all this, it's going to display the annotated image using matplotlib, and then it's going to print the results with the confidence scores. So let's see what this image detection actually does by running it with the Mona Lisa. As you can see here, it made boxes around the picture. And if you can see that little lettering right there, it says person, person, person. So that's what it's detecting as every single time. And listed below here are our confidence scores. So detected objects, it's detecting a person every single time because it is a person. So we have a 65% confidence rate and almost 100, and it's sitting around 90, 95 to 100 basically. So our algorithm actually solved and found that this was a person, which is really cool just to kind of see in action here with an image like that. Let's try another image here that's a little bit more complex. So we have another image here. It's a person wearing a backpack. So we have two things that are on the list of Coco names. So let's see what it does here and see how it handles this new image. As you can see here, this guy is wearing his backpack, but he's also standing within the image. So it's detecting the backpack while also detecting the person. Since the person is in front and kind of blocking the bag, it's kind of hard for it to detect, but it's still getting the person, almost 100% accuracy there that it is a person, but it's also detecting a backpack. So this machine learning algorithm is able to look at the image and then find the backpack in the back while also keeping the person detected. Let's try one more image here to showcase what happens if you pick an image that's not within the coco.names list. I have an image here of a tiger, which is not within the means of coco.names. So let's see what happens here and why you should always be aware of what image detection is really doing. So here it definitely finds the tiger and it's boxed it up. It's confident here that that is the image and that's what we're looking for within the image. But the detected object here is a horse because that is the closest thing that it could find to the tiger. And it's almost 98% confident that it is a horse. So what does this mean for our algorithm? Well, you have to be certain in the real world application here that the image you're detecting is actually that image. In the real world, this could happen all the time where something is not loaded properly or we don't have a clear image to go from or source in Coco names that really depicts that image. So that's where we come in and find errors of detecting images that aren't actually the correct image. And that's why you should always make sure when creating machine learning algorithms that you can account for this kind of stuff because you don't want to be 98% sure that a tiger is a horse.